everyone. In this video, we will shortly review the definition of operating system and we will move to the next concept between the software, hardware, and OS. Alright? Okay, as we learned before, what is operating system? Operating system, a layer of software. Alright? So, operating system, software, alright, not hardware but software. You should memorize it. As I mentioned, operating system is the top level software because it can control each hardware component based on the application scheduling and OS and kernel concept. So it controls all items of the computer sophisticatedly, right? So operating system is the Bible and top level software interposed between the application program and hardware. So have you ever periodically check your phone album? Phone photo, right? So as I mentioned in each video, please periodically check and watch your the photo of your cell phone every day, many times, because you can memorize all concept naturally and comfortably. Alright, so top level is application program, and below the application program, operating system is existed, and we can consider real hardware concepts such as processor, main memory, I/O devices. Alright, so please check the layered view of the computer system with your cell phone number photo. Alright, so operating system attempts to manipulate many and various hardware components to make the sophisticated scheduling and the execution. Alright, okay, applications go through the operating system to use the hardware as we imagined. Alright, okay, that is the definition of the operating system. And next page is the primary purpose of operating system. We already learned and mentioned and wrote each sentence in your written note, right? So please memorize a few or at least two sentences of the primary purpose of operating system with these slides. Operating system can protect the hardware from the misuse by runaway applications, right? Sometimes applications were attacked by other spammers, so original applications can have their unclear and the serious attack parts different from original intention, right? So operating system should keep track of each application status, right? So it is very important concept. It protects the hardware, alright? It protects the hardware from misuses by many kinds of applications, alright? And operating system can provide applications with a simple and uniform mechanism for manipulating complicated and often widely different low-level hardware devices. Alright, so when you look at the below figure, application program can help from the operating system regardless of types and the levels of the hardwares, right? So as you know, there are many kinds of the company of the hardware component, right? So each company can produce its own hardware with its own policy, right? So operating system can control and manipulate the complicated and different low-level hardware devices. So regardless of the types of hardware, we only installed the operating system based on our status, such as the 64 bits or 32 bits, or the type of operating system such as Windows or Mac OS. We only consider the type of the operating system, and then we can execute or install the various applications based on our interest, right? So I mean, we don't need to consider the company name or type or hardware devices because of operating system hub. Alright, so it is also very important. Operating system can provide simple and uniform mechanism to application systems. Alright, so OS can support hardware. Alright, and also can support or help many kinds of software. Alright, so you should know what is the primary purpose of the OS. Alright, and OS can also provide illusion that the program is only one running on the system. Alright, so simultaneously we can listen to music and do our reports with the PowerPoint or Word file with the KakaoTalk, the responding, right? How can it possible? Because the OS can provide illusion to each program is the only the one running at each epoch, at each slot, the small time epoch. Alright, so OS can do many roles, functions to software and to hardware. Alright, and OS can keep track of the state of information, context. So we will learn about the context, physical or logical meaning in future, so don't worry about it. So the process needs to run and do context switch. Alright, so with the OS we can check the current values of the program counter, register file, and contents of the main memory too. So OS can keep track of all status information of the hardware as well as the change of the software concept processes. Alright, so please take a look and take a photo of the below figure of these slides, and as I mentioned in the previous video, please memorize the left figure briefly, and you should know the primary purpose of operating systems with these sentences and this figure too. Alright, okay, we will move to the next page. So we will compare OS, process, and processor. Alright, can you respond each type of the OS, process, and hardware, considering the group of the hardware or software. Alright, as I mentioned, OS is software, process is also software. However, processor is hardware concept. Alright, so you should know the difference between three terminologies. Alright, so maybe you should memorize these slides all by yourself. So you should draw and write down all terminologies and figures in your notes at least 3 times, and please take a photo this slide with your cell phone, and please take photo your written notes as well as this figure, and you should paste all figures comfortably to your own portfolio Word file. Alright? Maybe you should submit within this week. You can upload your own portfolio Word file, and I can keep track of your file from first week and the first week. Alright? So please follow my video step by step and diligently write and take photo and paste and upload your old traces for yourself. Alright? Okay. So if you check the bottom figure in left side, we already familiar with this figure, right? And if you consider processor is one of hardware, and we can consider the number of the processor. If you consider a single processor, that means a single CPU. Most our laptop or desktops used a single CPU, because if you consider multiple processors, cost will be higher than ours. So if you are interested in game programming or more the advanced applications such as AI or the big data analysis, of course I recommend multiprocessors, the desktop or laptop. But that is the side information. If you if you can use the our university Linux server, I recommend most students use them for your homework, research, and application implementation, and so on in future. Alright, so I will talk about these issues step by step, so don't worry about it. So this figure shows the category of different processor configurations. All right, and if you are consider main memory and I/O devices as concept, these can be mentioned as virtual memory if we consider the procedure. I mean the flow executions in real time. If we can use the virtual memory terminology too. So we will touch the next or the future lectures, so don't worry about it. Okay, have you ever heard about main memory, or have you ever watched the main memory all by yourself? Main memory can be drawn the bottom figure in the right side. So main memory can be divided many the spaces according to the role or functions. Most main memory can be divided from the kernel part and the user part. So kernel part can be common to all processes. So it is very difficult concept, so we will touch in detail, so don't worry about it. As I mentioned many times through chapter 1, we can touch all chapters of computer system, right? So we can roughly, but importantly, I summarize all chapters. So we will spend the learning of the chapter 1, but don't worry about our process of the computer system. I will cover important and main part at the end of the final test, so don't worry about it. Alright, so as you can see on the screen, we can consider kernel virtual memory on top of the main memory part, and we can also consider user stack. So user stack can be created at runtime, and these parts are invisible to user code. So it is very hard and difficult part, and most kernel programmers or theory researchers are also very difficult to study and keep track of their current issues. But we will touch, so don't worry about it, alright? And after some empty spaces, we can also consider memory mapped region for shared library, such as printf function in hello.c file. Did you remember hello.c? The simple our first C programming code. We used the printf, the standard function. We did not make the printf function, right? We just type printf and we already successfully check the printing of hello world on the monitor, right? Because of this part. So printf or other many kinds of standard functions were existed in the center of the main memory part with the memory mapped region for shared library. Shared library equal to standard library, including printf and many kinds of functions. Alright, so we will touch with the C programming grammar, so don't worry about it, okay? And if you consider below part of the main memory, there are many spaces for users process. So we already made the hello executable file, right? So if we executed our hello.c file based on the compilation system, such as the 4 or 5 steps, as we learned about it, the hello executable files loaded in this part. So we can't change our executable file in future with complementing our C code, right? After printing out, we can also calculate or we can touch the system call. If you change our executable file, new executable file can be newly loaded in each the proper parts or space of main memory. So anyway, these are the user's process part. So first part is runtime heap. So it is created at runtime by malloc function. Malloc function is one of C programming functions. So the malloc is the abbreviation. Malloc function can make the space or location in a main memory properly, alright? And another part is read and write segment. So it is related with data part and read only segment. So we can also use the initiate or text or load function or file concept in C. So my point is, according to the process, the OS can divide each parts properly and put each proper the file in each memory space, alright? So process virtual address space, it is the snapshot of the Linux runtime memory image. So simultaneously and continuously main memory can be changed. So if you pause the main memory and if you take a pointer main memory, if you are possible, for example, we can observe or take a look the snapshots, the memory image similar to this, the right figure, alright? So dynamically the main memory status can be changed, alright? So we will learn about it in chapter 6, so don't worry about it, okay? And as I mentioned, if we opened the putty and if we wrote the swing.skku.edu, the IP address is the same and port is the year of the establishment of Seongkyungwan University. And if I try to open it, I can connect with my ID. Alright? So this is a shell, alright? So if I connect the shell process is the process A. So my operating system can detect, oh, professor or user open the process A. The process A name is shell. Alright? Sometimes the process can be changed to another one, such as the KakaoTalk or your Word file or Explore or my PowerPoint or Everett and so on. In my case, there are many cases process at this epoch. I newly made a new process A, the shell process. So operating system can detect a new process, name the shell. Alright? So process A can read my command, for example. So if I put the ls, I can check all my files as well as executions and data. So ls means please show all files in current directory. That is one of the command. Alright, so you can use it to check it, right? So if I put ls, the OS can read my comment and try to execute the meaning of ls. So process can't find all items and files and shows the result on my terminal, right? But if I try to execute my executable file, hello or hello.2 with current directory special keywords, even though we shortly respond the result hello word on my monitor with the terminal, but inside the process B was made and hello process was executed. So hello process can be composed user code and kernel code. So user code means the hello to the C, right? So hello to the C file already executed with the compilation system, and hello.2 was loaded in this part because it is related with the user process, right? And kernel cooperated with this code with the operating system. So operating system simultaneously controlled my speaker, my terminal process, as well as my lecture slide. So based on the specific and sophisticated scheduling, operating system can cooperate with the kernel and at the proper time shows the result hello.word with this part, right? So if you compare the bottom figure and top figure in the right side, the user code and kernel code that is occurred with the context switching with the operating system. And again, user code written to the shell hello.word and the terminal, I mean the shell process shows the hello word. Alright? So if you are consider only two process at this example, this is the process A, alright? And hello2 is the process B. So on top of the operating system, processes can be switched and executed naturally and if there is no error of the C programming grammar, the final result was occurred in the terminal. Alright? So this concept is very important and complicated and difficult for us because the operating system is new topic and the compilation system as well as computer systems are new to most students. Most students are not electrical or computer science major part, right? So most students were more difficult to the track of the concept of the operating system and the C programming language, Linux, and computer structure and system concept. But don't worry about it. As I mentioned many times, I will touch the main and important part and slowly and based on your status with your word portfolio file and your questions, I will teach the proper level with all concepts. All right? Okay, don't worry about it. Okay, so as we already mentioned this slide, process is the operating system abstraction, okay, for a learning program. Okay, so we already learned the shell process and hello process. So these are learning programs, right? But we can't open terminal one more. Like that. Alright? That is process C. So we can make many processes. Alright? How can we do that? Because of operating system. As I mentioned, operating system can make abstraction for a running program. Alright? So operating system and the process and operating systems abstractions are the software concept, not hardware. Alright? And multiple processes run concurrently on the same system. The same system means same desktop or my laptop, and each process appears to have exclusive use of hardware. That is process abstraction. Okay? So, for example, this putty program only consider, oh, I am here only and I can fully use my hardware. How about this process? This process also consider, I only was acquired in the Hayoung's computer and I can fully occupy Hayoung's hardware. That means I can learn everything if I want. So each process are independently and each process are hidden. Of course, we can touch the communication or the relation between processes with the advanced concept, but at this epoch, don't worry about it, okay? So that means multiple processes run concurrently on the same system, and each process appears to have exclusive use of hardware. That means a process abstraction on top of operating system. Alright? Okay. So, if you consider the last figure of this video, it is more complicated, but we already learned about the most part. But there is the number steps for understanding in detail. So you should consider two division. So bottom is the hardware and top is related with the software concept. Okay, if you open the shell, we can't log in and execute hello executable file, right? At this epoch, shell process used operating system with the system call. What is a system call? We will learn it in detail in future, don't worry about it. Anyway, system call means shell process can use the operating system. If you want to use the operating system part, that means system call. Okay? So, if you concurrently or continuously consider the change of the main memory part, the number one is related with the user part. Number two is related with operating system call. So the top part of the memory is related. Alright? And in the kernel code, the operating system allows, okay, at this time, the hello executable file can be executed. So operating system can take a look and observe its own scheduling table and select or decide the proper epoch very quickly. So after that, the response to the shell process. So shell can't touch the executable hello file and response at the proper time on the monitor terminal. And finally, the finish of the executable file too. Okay, so if you consider simultaneously software part as well as the real hardware part, you should follow and check each steps from 1 to 6, and please pause my video and please write down this figure and draw this figure many times in your notes, at least 3 or 4 times, and please close your eyes and imagine the operating system and process concept as well as hardware such as the CPU, specifically main memory part. Alright, so in this example, there are only 2 system call and 2 context switching and 3 calling or UCCs, at least 3 calling or UCs of the user parts of the main memory. Okay, so these are process abstraction. So implementing the process abstraction requires close cooperation between both low-level hardware and operating system, as I mentioned. Okay, so please review this video many times and write down and take photo and upload your photo to your portfolio Word file. Alright, okay, thank you for listening. See you next video. Bye bye.